My levels of nagging are hard. I am an all right. The hint I've been sending to people in the chat is what is the radius of the circle? That will be the hypotenuse of the triangle. So, Jack H, what is the radius of the circle?
It would be 3.
3. So that means that 3 is the hypotenuse. Now, some people needed a second hint, and my second hint was we know that 128 is supplementary to this acute angle in the red triangle. Catherine, what is this angle?
55.
55. So then we were able to set up 2 trig ratios, one for X, one for Y. Jesse, give me one of those ratios. $180 minus 125 gives us the 55. Jesse, what if we were looking for Y? Would we use sine, cosine, or tangent?
Sine.
Sine. So we're gonna say sine of 55 equals Y over 3. And Jesse, what are we gonna do to both sides?
Multiply by 3.
Multiply by 3. We get Y equals 3 sine 55 degrees. And we actually want that angle or that length, and we end up with 2.46. Okay. Now for X, Avery, if we're looking for X, are we going to use sine, cosine, or tangent to find X?
Cosine.
Cosine. So we're going to say cosine of 55 equals what?
X over 3.
X over 3. And then what are we going to do to both sides?
Multiply by 3.
Very good. And when I put that in my calculator, I got 1.72. Agree? She nodded. Okay. Now, what's up?
You just like skip the X over 3 part?
No, you cannot.
Like I can't
You cannot.
put 3 parts.
I answered your question. You cannot. Because I don't believe any of you are that good yet. And you did not have a full geometry class. And therefore, I need to see all the work. When we hit a point where we can start skipping things, I will let you know. Ladies and gentlemen, we have found these 2 lengths. These 2 lengths exactly do not make up the ordered pair under the blue rectangle. I want everyone to privately send me the ordered pair of the point. What is the ordered pair of that blue point? If you know it, send me what. There we go, Catherine. What is the ordered pair of the blue point? There you go, Emma. There you go, Gavri. Alice Tomas, try again. The blue point, like not the one I circled in blue, this one. What is this blue point? There you go, Jesse. Miku, try again. It's not exactly these 2 values. There you go, Alice. There you go, Jack H. There you go, Claire. Alice, what did you just send me? There you go, Hayden.
Negative 1.72 and 2.46.
Why does the 1.72 need to be negative?
Because you can see that like the opposite side is in the negative values.
Yeah, like when I go here, when I find this point, I have to go to the left. Whenever I have to go to the left, it's negative. If I was going down, it would be negative. I had a couple people send me some other things in the chat. Are there any questions now, bravely out loud, privately in the chat, why this ordered pair is negative 1.72 and 2.46? The 55 degrees is because it is supplementary to 125. I did 180 minus 125. Okay. All right, ladies and gentlemen, today we are going to stop thinking about Ferris wheels and start thinking in the abstract sense. But we're going to keep the idea of Ferris wheels to help us guide our thoughts. We are still going to think about the point as a rotation, like moving around like Carlos's Ferris wheel. The difference is that we're not going to be off the ground anymore. So this is what I want everyone to do. People who got the hint, I told you that to look at the what of the circle. Elena, you got the hint. What did I tell you to look at on the circle? What property? I said to look at the radius, and that would be the hypotenuse of the circle. I want everyone, or of the triangle, I want everyone to label the hypotenuse as R. Moving forward, we are going to have this imaginary circle around our triangle, and the hypotenuse of the triangle will be the same as the radius of our circle. So let's say instead of having theta here, or sorry, instead of having 55, we had angle theta in this position. If we were looking at the sine of angle theta, and no numbers, just letters, Samantha, what's opposite angle theta?
Y
And what's the hypotenuse?
2.46.
No, just y, babe.
Okay.
Y over what?
R.
Y over R. Oop, that was not an R. Okay, so then if we were looking at the cosine of theta, hey, Brooke, what's adjacent to angle theta?
X,
And what's the hypotenuse?
R,
Okay. Hey, Lily, if we're looking at the tangent of angle theta, what's opposite angle theta?
Y over X.
Y over X, very good. Okay, so we are going to rewrite SOHCAHTOA this way. Now, if you want to write like opposite, hypotenuse, adjacent, oh, that's ugly, hypotenuse, opposite, adjacent, because you're still like a little rusty dusty on SOHCAHTOA, that's cool, I don't mind, put that in there also. But I need everybody to write down these three symbolic definitions of sine, cosine, and tangent. Okay. Ladies and gentlemen, we are going to go today, like I said, from the tangible to the abstract. On Carlos's Ferris wheel, we always started at position A. I want everyone to make a nice, hopefully yours is a straight line, a nice arrow on this positive x-axis. And I want you to label this. This is going to be what we call the initial ray. It's going to be our starting ray. Just like Carlos always was looking at that, chair letter A that was on the far right, we're always going to start from this initial ray. Then what I want you to do is I want you to put a nice thick line on the hypotenuse with an arrow. The initial ray is where we start. We're going to end at the terminal ray. And what we now have here in this graph is we have 125 in standard position. Okay, this is a standard position angle. Every standard position angle has an initial ray, that's the positive x-axis, and then it rotates. If it's a positive angle, it rotates counterclockwise, like the Ferris wheel. Here's our positive measurements. And if it's got a negative measurement, it's going to come down. It's going to rotate clockwise. All right, so this is what I want you to think about. We got space at the bottom of this page, right? There's like some nice white space down there. Yeah, we're not gonna waste that nice white space. We're gonna sketch a few angles in standard position. So here's the first one we're gonna do. We're gonna do that's ugly. We're gonna do 200 degrees. We're gonna sketch 200 degrees in standard position. So first I need to draw an XY axis. Those of you who have two color writing instruments, it's nice to have two colored writing instruments. We're going to start on the initial ray. We're going to rotate counterclockwise. Hey, Claire, are you there?
Yes,
All right, so if I rotate to this point, how many degrees is that?
90,
To here, how many degrees is that?
180.
180. So I just need to go a little further, right?
Yeah.
Miss Strauss is not an excellent artist, is she? Say no.
No.
As long as you're in the the right area, like if you're in the middle, that's okay. Here's 200 degrees. Okay. There's 200 degrees. Now, Claire, this little angle right here, how much past 180 does 200 degrees go?
20 degrees.
Oh, that's ugly. 20 degrees. So everybody mark that little angle. 20 degrees. Now we're going to do another nice, easy number. We're going to do 300 degrees. We're going to sketch 300 degrees in standard position. So we're going to start positive x-axis. And we're going to rotate counterclockwise. Alice, are you there?
Yeah, I'm here.
Okay, ready? Here we go. What's that?
Uh,
How many degrees?
Hold on.
Hold on.
Wait, no. 60?
No. There you
90.
go. 90. How many degrees is this?
180.
Good. How many degrees is this?
240.
Close. 270, but 240 was close.
Okay.
Okay, so we need to go a little bit further, right?
Yeah.
Somewhere in the middle.
Yeah.
We don't want to go all the way back to the starting arrow because that would be 360 degrees. So we're all going to be like, boop, and we're going to mark that angle 300 degrees. Now, Alice, are you ready?
Yeah.
Hey, guys,
Guys,
no one cares about the angle
no one cares about the angle
between the terminal ray
between the terminal ray
and the y-axis.
and the y-axis.
It's trash.
It's trash.
Don't look at it.
Don't look at it.
Don't look at it, guys. All right. What we care about, Alice, is the angle between the terminal ray and the x-axis. So let's think about this. If this is 300, how much is left before we go all the way around?
60.
60. Okay. Are there any questions on how Claire and Alice were able to come up with these two red and blue angles?
How do you get 60?
Because, Alice, how did you get 60?
Because like the thingy around it that we marked is 300 and the whole circle is 360 and 360 minus 300 is 60.
I couldn't hear that well. Could you speak up again?
Sure. She said she knew the whole circle all the way around was 360 and the angle itself is 300. So to figure out what was left, she did 360 minus 300.
Okay.
Okay. I want everyone all by yourself to sketch 100 degrees in case you see a theme here, trying to keep the numbers nice and easy. 100 degrees. Everybody sketch 100 degrees in standard position. Whoa. I do not know how that happened. That little person, where did that just come from? Well, I don't know what just happened. And it's like, I think I hit something that it turned my hand. I don't even know. That was cool. Wait, I'm gonna type. No. I don't know, guys. That was scary. But also kind of cool. I want everybody to sketch 100 degrees in standard position. Okay. I want you to type to the chat to everyone, what quadrant is the terminal ray for 100 degrees in? What quadrant is my terminal ray for 100 degrees in? 1, 2, 3, or 4? Type it to everybody. 1, 2, 3, or 4. Where is the terminal ray? Press enter. Hey, look at all those right answers. It's in the second quadrant. So this is what I meant when I was trying to get Claire to call me a bad artist. That's why I was a little weirded out by that person, because I thought that would be something I draw. Like, you can just toss it in there. You don't need to be like real precise. Now, Alice, do we care about this angle?
Yes. No.
The angle between the terminal ray and the y-axis is what?
The proposed measurement? Trash.
It's trash. It's trash. We don't care about it. We care about the angle between the terminal ray and the
x-axis. Standard position.
Okay, ready? Say x-axis.
Okay, yeah.
Yeah, all right. I need everybody to find this little pink angle for me. Mark it on your picture. Send it to me privately. What is this little pink angle? Good. Very good. Very nice. All correct answers coming in very fast. Good work, guys. Lauren, what did you send to me?
80 degrees.
80 degrees. You know what, Lauren? I think this angle needs a name. Don't you think it's so important?
Yeah.
Okay, I'm going to name it Bob. No, I'm not really doing that. This is our reference angle. I want everybody to, well, I spelled, no, that's right. Reference angle. Okay, this is our reference angle. So over here, 55 is our reference angle. We're going to talk about why it's called a reference angle. Over here, 60 degrees is my reference angle. Over here, 20 degrees is my reference angle. The reference angle, and this is written on the next page, don't worry. The reference angle is the angle between the terminal ray and the x-axis. The x-axis, not the y-axis. Y-axis is trash. Sorry, y-axis, but you're trash. All right, no one cares that this is 10. No one cares. We want the angle between the terminal ray and the x-axis. Here's why. I want everyone to look back up here. Hey, Charlie, are you there?
Yes.
Charlie, when we found this x and y, did we really use 125?
No.
No, we did not. What angle did we use?
55.
55 is the
Reference angle.
boom. That's why the reference angle is important. If we are calculating these values using right triangle trig, using symmetry, if I want to find the values of 128, the sine and cosine, I have to know its reference angle. And really, I'm finding the sine of 55 and the cosine of 55. But I have to remember that because I've overlaid this on an XY axis, this X value here is negative. Okay, and that's why this was negative 1.72. Are there absolutely any questions on this introduction to the definition of sine, cosine, and tangent as a function of an angle of rotation? Is there any questions on anything I've written on the board so far? Bravely out loud, privately in the chat. Do you want to do one more angle, or do you feel okay? Everyone want to do one more? Does anybody want to suggest an angle? One more, someone says. Someone said, give me a number. Send me a number privately. My favorite one I'm going to make you do. Let's see what kind of suggestions we get. What angle? Okay, so someone has suggested, oh my gosh, you guys are mind readers. Is that because it's my favorite angle, 30 degrees? All right, I got 2 suggestions. We're going to do both of them. We're going to do 30 degrees and we're going to do 191. I want everyone to sketch these 2 angles in standard position and find the reference angle. Boop, 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 boop. I like to make my initial ray red because it's very bright. Okay, 30 degrees. This seems like a trick. I need everyone to send me what quadrant 30 degrees has a terminal ray in. 30 degrees. Where is, there we go. Good job, guys. You sent it right to me. It's in the first quadrant. Here it is, 30 degrees. Okay, now, this is a little ridiculous because I need to know what the reference angle for 30 degrees is. Catherine, are you there?
Yeah.
Okay, I have a question. Is 30 degrees an acute angle?
Yeah.
Can I draw a triangle with a 30-degree angle in it?
Yes.
Okay, so 30 degrees, if I'm looking for the angle between the terminal ray and the x-axis, if I'm running from the terminal ray to the x-axis and I want to run there fast, what quadrant should I run to?
Well, I don't.
Like, should I go here or should I go here?
To the right.
Oh, to the right, yeah. Okay, so if I'm in the first quadrant, what's the reference angle? It's like funny because it's its own reference angle, isn't it? I don't need to sketch it. 30 degrees is just like, look at that. There's 30 degrees. I could draw a little triangle, 30 degrees. And I could just, right triangle it up. 191. What quadrant is 191 in? Send it to me. Where is the terminal ray for 191 degrees? Good, Oscar. There we go. Now they're coming in real fast. Very nice. Lots of fast answers. The third quadrant. So here is 191 degrees. Ooh, that's not so neat. Okay. The reference angle. I need to think to myself, and I want everyone to go up here and label this. We're going to label this. I'm going to do it in a big pen. This is 0 degrees. Hey, Amalia, how many degrees up at the top here? How many?
90.
Good, good. 90. And Amalia over here?
180.
Lovely. And down here?
270.
Perfection. And if I go all the way around, what do I end up at?
360.
360. So I need to know that. So if I'm looking for the reference angle here, I have to remember that this is 180 and this is 191. And I really want to focus on what arithmetic am I going to do to get that little angle. Hey, Sam, can you unmute yourself and say what you just typed to me?
191 minus 180.
There you go. 191 minus 180 is how much?
11. Oh, 9.
You're right.
Oh, okay.
Okay. Let's make a little cheat sheet. Ready? Reference angle. All right, we're going to draw an XY axis. If we are in quadrant 1, And I think some people are getting a little messed up here. If you are in quadrant 1, the angle is the reference angle. Like whatever, if you have an angle less than 90 degrees, that's really ugly. You don't need to worry about it. You're good. That angle is your reference angle. So we're going to do what Sam said. If you're in the third quadrant, we're going to take the angle and subtract 180. Now, if we're over here in the second quadrant, like when we were up here with the 100, someone typed to me, what arithmetic can we do? How did we get the 80 from the 100? What did we do? What specific arithmetic happened to get that pink 80? Somebody type it to me. What specific, Catherine, what did you say?
Subtracted 100 from 180.
We're going to do 180 minus the angle. There you go, Grace. That's exactly what I was talking about. So now over here in the fourth quadrant, I want everyone to think to yourself, this blue one, how did we get that reference angle for 300? What arithmetic, specific arithmetic happened? Everybody think to yourself. If you want to send it to me because you want to like double check it, that's cool. Because I got a couple people that have already sent it to me. There we go. Oh, I like the way Elena wrote it. That was very nice. Okay. People who are saying subtract this from this, I want you to like actually write out an elementary school piece of arithmetic. So Lily, what did you type to me?
I said 360 minus 300.
Okay, 360 minus 300. So someone said 360 minus the reference angle. I want to be clear. This is what gives you the reference angle. Okay, like this is how we're going to find it. We found the 60-degree angle by doing 360 minus 300. We found the 20-degree reference angle by doing 200 minus 180. Okay. I want to pause here, do some announcements, and then we'll get back into this conversation. I have some very important announcements. There's a major typo. There's a major typo. I need everyone to turn to the homework right now. Go turn to the homework. The homework is on, it looks like, let me find it for you. It looks like this. I need everybody right now. There's a major typo. It says angles with positive measure rotate clockwise. That is incorrect. And angles with a negative measure rotate counterclockwise. That is incorrect. I need you to see where I have these green crossouts. I need you to take care of these, cross these out. Boop, this, cross it out, and this is correct. Write that in. You guys see where it says rotate and then there's a blank? Write those in and then cross out the words. Do me a favor and type done to me when you have made this correction, because it is a very, very important correction that I need to make sure you have completed. Okay, if any problems ask you to answer in radians and degrees, guys, you can just skip the radians part. We are not going to get to that this year. It is okay. I promise you will spend a lot of time in pre-calculus talking about radians. It's okay if we don't get to it this year. All right. I got a lot of dones coming in, so I think we are good to go. I want to take a look at last night's homework because, like I said, today is the day we're going from the Ferris wheel to an XY axis. So in last night's homework, a couple people had these values, and I asked you to please not use these values, but to stay with the angle of rotation. Okay. So here, the angle of rotation, for example, was 192. Okay. So I wanted you to think about that as 192. I had a couple of people ask me about 9 and 10 and 11, and a couple people were honest, like I just looked at the answers. How did the positions of the triangles change? between 5 and 7 seconds. Between 5 and 7 seconds, they got taller because you're just going from 5 seconds to 7 seconds. Here, how did the triangles change between 14, 15, and 16 seconds? Let's switch colors. All right. So 14 seconds. Hey, can someone do me a favor? Because this is not what I want. Ashwari, did you do the multiplication here? 12 times 14? Okay. What was the angle right here? Instead of 12, what did you have there? What was 12 times 14? 1. Okay, she wrote down 12 times 14. Thanks, buddy. I think it's 1. What's up? That seems right. All right, so here, I'm right here at 14 seconds at 168. Now, at 15 seconds, you should have gotten exactly 180. At 16 seconds, it should have been 192. Okay, so how did the triangles change? 14 seconds, we are in quadrant 2. At 15 seconds, we are right on the line. At 16 seconds, we've kind of moved down into quadrant 3. So same thing here, 22 to 23 seconds, it's going to move from quadrant 3 to quadrant 4. Instead of thinking of this as a Ferris wheel now, we're going to start thinking about this as quadrants 1, 2, 3, 4, and we're going to think of these as the XY axis. Okay. Any homework questions? Once, twice. Okay. So on the next page, we have some, I promised you I would have those definitions for you, and there is our definition for reference angle. The reference angle is measured from the terminal side of the original angle to the x-axis. To be in standard position, we're going to start on the positive x-axis, and we are going to go counterclockwise. Ladies and gentlemen, I want everyone to highlight or circle 0. Man. Highlight or circle 0 degrees, 90 degrees, 180 degrees, 270 degrees. Everyone to highlight them. So the question just came in, are we still having class Thursday because of AP exams? Yes, if you miss my class because of an AP exam, you are to watch the video that night. I want everyone to make a note that these angles 0, 90, 180, 270, and even 360, they are special angles. Now they fall on the quadrant line. See how like we've divided up, this is the first quadrant, the second quadrant, the third quadrant, the fourth quadrant, they fall on the quadrant lines. This is, I love this because it's very literal. These are our quadrantal angles. All right. These angles that are multiples of 90, I want you to please make a note that they are quadrantal angles. They get a special name because they don't, like, I can't draw a triangle for them. They are special. Okay. From the warm-up page, we wrote down Sine of theta, Oscar. What did we write down for sine of theta?
Equals y over r.
Good job. Oscar, what did we write down for cosine of theta?
X over r.
Very good. And for tangent of theta?
Y over x.
Good. Everyone write those down again. Okay. The way we evaluate sine, cosine, and tangent for angles larger than 90 degrees is to use the symmetry of the circle and use what we know about the signs, the SIGNs of the ordered pairs in these quadrants. For example, over here, X is negative, Y is positive. This is what I want everyone to do. Underneath these, I want you to write plus, plus, minus, plus, minus, minus, plus, minus. Now, R, Andy, what did R stand for here? This R, what's the R?
Radius.
The radius. Now, let's think for a second, Andy. The radius, is that going to always be a positive value or always going to be a negative value?
Positive.
Positive. So I want everyone to make a little note here. The radius will always be positive. We're going to pause from this abstract conversation for a second and think, if I was on the Ferris wheel and I was at this position right here, and I wanted to find the height off the ground, I would take the distance the center was from the ground, and I would subtract this amount. Is this familiar? When we were on the Ferris wheel, if we were looking for this point, we would take center from the ground and we would subtract that amount. Familiar? Okay, here's what happens. Let me get rid of this garbage. Tangent is y over r. Sorry, sine is y over r. In the third quadrant, y is a negative value. So it's going to be a negative value divided by a positive value. Always, man, she's having internets today. Is always going to be a negative value. That's why people who looked at the answer key, they were subtracting that value. But those of us who were just using our equation, we were just able to use the angle as it is, because the sine of any angle that falls here gives us a negative value. If I'm in the third quadrant and I'm looking at the cosine value, Tomas, x over r, what's x in the third quadrant? Is that a positive value or a negative value?
Negative.
Negative. The radius is always
Positive.
So a negative divided by a positive is a
Negative.
negative. All right. So let's all think about tangent for a second. If I'm on the Ferris wheel and I'm down here, Miku, tangent is y over x. In the third quadrant, y is what?
Negative.
Good. X is
Negative.
a negative divided by a negative is a
Positive.
That means that any angle that has a terminal ray in the third quadrant will have a negative sine value, a negative cosine value, but a positive tangent value. We're going to do the same thing in the second quadrant. We're going to say sine, cosine, tangent. All right, Emma, here we go. Y over R. If I'm in the second quadrant, is Y positive or negative?
Positive.
R is
Negative. Oh, positive.
What's a positive divided by positive?
Positive.
Okay. Hey, Hayden, if I'm in the second quadrant, cosine is x over r.
X is negative, R is positive.
Divide it and you get a,
Negative.
that's sad. I like positive numbers. Hey, Marco, if we're in the second quadrant and we're looking for the tangent, y is, oh, he left. He went somewhere. Hey, Godfrey, if we're in the second quadrant and we're looking for the tangent, what is y? Positive or negative?
Positive.
Positive divided by a
Negative.
is a,
Negative.
man, hey, Godfrey, what's the only thing that came up positive in the second quadrant?
Sine.
That's depressing. I like positive numbers. All right, let's look at the fourth quadrant, guys. Hey, Hannah Banana, if I'm in the fourth quadrant and I'm looking for sine, y over r, is y positive or negative in the fourth quadrant?
Negative.
Radius is,
Positive.
that makes a,
Negative.
yep. Hey, Iris, what about cosine?
Is it positive?
Divided by
Positive.
is a,
Positive.
all right, what about if I'm in the fourth quadrant, Jack break, and I'm looking for tangent? Y is, x is, and when I divide that, I get a, man, that means only the cosine is positive. Now there's one quadrant I have not done. Abby, which quadrant have we not done yet?
The first one.
The first one. Now, what are x and y in the first quadrant? They're always what?
Positive.
So like if I go through this, Abby, and I go sine, it's going to be positive over positive. Oh, that came out really, I don't even know what happened with the handwriting. Sine is going to be positive over positive. Cosine, Abby, is also going to be,
Positive over positive.
and tangent is going to be,
Positive over positive.
guess what, Ab?
What?
No, you tell me what.
Oh, they're all positive?
Yeah, they're all positive. Ladies and gentlemen, there is an acronym that is old as the hills to remember this. In the first quadrant, everything is positive. Sine, cosine, and tangent. In the second quadrant, only the sine is positive. In the third quadrant, only the tangent is positive. In the fourth quadrant, only the cosine. A, S, T, C. It's universally known as all students take calculus. Some kids learn all students take courses. All students take cafeteria. You can come up with some inappropriate ones on your own, I'm sure, about what all students could take. I will leave that to your imagination. I went to a high school that started with a letter A, so there were lots of inappropriate things we came up with. But this is just a way for you to remember, if my terminal ray is in this quadrant, this is what I should get in terms of an SIGN. Think about what I just said, SIGN. SIGN, like, is it positive or negative? The SIGN. This was a lot. Take a minute, look at it, take a breath. Questions? I like to lay out all this theoretical information before we get into the Carlos and Carlita ridiculousness, because I feel like otherwise you have no background knowledge. So I want everyone to turn in your packet to where it says more sign language, and I want you to read the little scenario right here. Everybody read this scenario, and I want you to answer number one on your own. I want everyone to read the scenario. You can, using the background knowledge that we just went through, I want you to answer number one on your own. you want to send me some angles, because you need to just be like, am I on the right track here, Strauss? That's fine. I'd love it to see what angles you've written down, because I can't walk around and look at your paper. It's very depressing. All right, I already got 2 good sets of angles, and I got 1 person who's on the right track. I've got 2 nice sets of angles, and I've got 1 person who's on the right track. So send me, when you've thought of some angles, send them to me. Hey, Hayden, can you unmute yourself and say what you typed to me?
I said any angles between 0 and 180 degrees will have a positive sine value.
Any angles between 0 and 180. Oh my gosh. How did I end up in this font, guys? And also, where did the cute little person go? That's better. Will have a positive. All right, so I have a question. Why? Why will any angles between 0 and 180? And so, like, for example, some of the people gave me like 30, 60, 80, and then they also gave me 120, 145. I got 100, I got 120, I got 60, 30, 90, 50, 10. Those were all good. Why are 80, 60, 100, 170, and 5? Why are all of these good? Why is it that quadrant 1 and quadrant 2 have positive sine values? How come? Hey, Jesse, what's the definition of sine using X, Y, and R? He might have fallen out. He had some internet. Oh, he's back.
Y over R.
Y over R. And Grace, can you please read what you just typed to me? Because it was fantastical.
I said because the y is positive and the radius is always positive.
Because BCAUSE in quadrant, I'll fix that in a second. In quadrant 2, the y is always positive. And R is always positive, like always. I'm going to edit your answer for just a little bit. I'm going to make it say quadrant 2, 1 and 2. Is that okay?
Yes.
Yes. I do not even know how I ended up in this font color or this font size. I think this computer is possessed. Better. All right. And R is always positive. Do you want me to put that in there too?
Sure.
I'll add. Okay, so I want everyone to write a similarly well-worded answer to number 2. And it's okay if you typed in all caps. Sometimes I type in all caps, mostly when people owe me work. You get an all caps message. I want everyone to write a similarly excellent answer to number 2. So Avery, in what quadrants is sine negative?
In 3 and 4.
In 3 and 4. Hey, Marco, will you read what you typed to me?
Okay. Any angles between 180 and 360 will have a negative sign due to quadrant 3 and 4 having y equals negative.
Well, he said due to, I'm going to be specific, due to quadrants 3 and 4 having y being negative. Okay. Are there any questions on 1 and 2? So Carlita is having a smart moment. Good job, Carlita. Carlita says, there are some positions on the Ferris wheel that I can't even draw a triangle for, but the calculator will still give me values for sine. There are some special angles. We wrote down the name of those special angles. Not quadratic, but it's a Q word. What angle can we not draw there we go. I got one person found it. Oh, now they're all going to come in real fast. They are our quadrantal angles. Good job, guys. Good note taking. Some people even spelled it correctly. So like, for example, that would be 90, 180, 270, 360, 0. We can even have negative 90, etc. Anything that's a multiple of 90, positive or negative. We're not going to give the sine value for those right now. We'll worry about that later. Okay, now I want to do 2 more problems, but I don't want it to be so open-ended. Okay, so then Carlos, he's feeling smart too because he doesn't want to be outdone at the fair, looking at the Ferris wheel and talking about math like the bunch of geeks they are. Carlos says, because of the symmetry of the circle, some angles have the same value for sine. So here I'm gonna make you a list. So like 20 and then you fill it in. And then we could have 100 and blank. We could have, let's go with 210. We could have, I'm just going to try to keep them nice, like multiples of 10. Using symmetry, if I have 20 degrees, I'm going to draw you a little picture. So here's 20 degrees. What's over here? Okay, 20 degrees. Okay, so be careful because it's got to be right across. Someone gave me 110. 110 would be up here. I need this to be 20 degrees also. There we go, Jacob and Marco and Grace. Hey, now they're all coming in. Okay, it's not going to be negative 20. It's going to be 20 and 160. Right, because first quadrant, second quadrant. Right, 100. So I have 100 degrees. 100 degrees is right here. $100 and what? Emma, you got that really fast. Can you explain to people? Because not everyone's sending me the right answers.
Because 100 is 10 degrees over 90, and then so you just subtract 90 with 10, so you get 80 degrees.
Yep. She also could have looked at that the reference angle for 100 is 80, and so 80 over here. Okay, if you want to go ahead, send me the answers for 210, what matches with 210, and what matches with 310. I'll give you a hint, they're not buddies. 210 and 310 are not best friends. 210 has the same sine value as what? What's directly across from 210? I don't think that's in the third quadrant because 90, 180, here's 210. There we go. The person who sent it to me with a question mark, good, do the next one. Okay, 30 degrees, friend, would be in the first quadrant. Remember, sine is positive up here. Sine is negative down here because all the y values are negative down here. So I'm at 210, that's going to be a negative. I need to know which one is symmetrical, which one's directly across, like who's right there. There we go. Oh, I like how he expressed it as a negative angle. That was fantastic. Okay, so if we're at 210, I gotta think my reference angle for 210 is 30 degrees because 210 minus 180 would be 30 degrees. So if I put that 30 degrees over here, that would make this 330. Or someone has put it as negative 30. I like that also. Negative 30, that's good. It's clever. For 310, well, 310 somewhere in the fourth quadrant here. I don't know. It's over here. So I have to think, all right, who's symmetrical? So I have to think, well, if this is 310, my reference angle is going to be 360 minus 310. There you go, friends. That's going to be 50. So if I put 50 over here, this is 180, and I think, all right, well, that's 180 plus 50 is going to be 230. I don't want to do every question from this Carlos and Carlita situation, but there is one more I want to do.
What about negative 50?
Negative 50 is good also. I'm gonna add that in. All right. There's one more question I want to do, and then we'll call it a day. Maybe. Hold on, I got the circle of death. There it is. Carlita says, if we go around the circle more than once, the calculator still gives us values for the sine of the angle of rotation, and multiple angles have the same value of sine. So I need everyone to imagine. If I go here on the Ferris wheel, or I go all the way around, but I land at that same terminal ray, the sine value will come up the same. If you have a calculator handy, I want everyone to put sine of 30 into your calculator. Unmute yourself when you get the answer. Just say what it is.
1/2.
1/2. That's why it's my favorite. Okay, so if I go all the way around and then an extra 30, what's 360, one rotation plus 30? Yeah, it's 390. Just for fun, toss it into your calculator. Sine of 390. 1/2. Yes, ladies and gentlemen, these are called coterminal angles. And I love this word because it just makes sense. Coterminal, sharing the same terminal ray. They're coterminal angles. They're best friends. They share the same terminal ray. Like I could do, and I could go the other way around. I could go like, wait, let me get a red pen. I could be like, wee. And that would be sine of negative 330. And it would still be 1/2 because it has the same terminal ray. Ladies and gentlemen, we have covered a ton of vocabulary today. All right. I want everyone to make sure tonight's homework, you've made this correction. I want good sketches. This is tonight's homework. Snap a picture. If you have no questions, you are free to unmute yourself and say goodbye. If you have questions, you please